my name's Evan Derdall. I'm an irrigation drainage engineer based out of Saskatoon, but I grew up in a small town, Outlook, Saskatchewan, which is just located south of Saskatoon. And I grew up on an irrigation farm with my father used to sell the equipment. So I do have some, irrigation's been in my whole life. So I'm just been asked to share just a bit about irrigation in Western Canada, kind of how we operate and how we approve and how we're working towards improving efficiencies in our irrigation systems. So just generally, Canada has about 1 million hectares of irrigated area. This is loosely based on provincial reportings in Statistics Canada. 80% of that, though, is located in this semi-arid to arid region. So Saskatoon, Calgary, Regina, it's also kind of referred to as the Palliser Triangle. But as you can see, Alberta continues to have the lion's share of the irrigated area with almost 650-ish thousand hectares of irrigated land. Saskatchewan's at about 137,000, and Quebec is 22,000. So irrigated volume, again, as you look at the distribution, about 71% of that water is used in Alberta. Approximately 9% are used in both BC and Saskatchewan. The majority of crops grown are field crops. So you're looking at your canola crops out in Saskatchewan, beans. There are some wheat acres that are irrigated, but again, that's more for rotational purposes. There is a large majority of hay and pasture land that's located in southern Alberta. That's for feed for cattle. There's a heavy livestock industry in southern Alberta in the Lethbridge area. And then the remaining 13% are in fruits and vegetables. So water sources on farm, Canada is a little bit more unique compared to the United States in that the majority of our water is on farm is surface water, so rivers or lakes, or on farm surface, which we refer to as like it's diverted from these rivers or lakes through irrigation districts. So over 80% of our water is surface water, where a good portion of the United States uses groundwater, and that's where they've come into some issues with aquifer depletion and over the last few years. So just as a little bit of a visualization, the majority of our surface water in Western Canada comes from the Rocky Mountains in the form of snowpack or receding, melting glaciers. As it travels across the Saskatchewan River Basin, there have been some large earthen and concrete dams installed along these rivers and tributaries. This image here is actually the Gardner Dam at Lake Diefenbaker, not far from where I'm located. So from these large reservoirs, the water is diverted into supply canals. These main supply canals provide water to balancing reservoirs. They can use the water for recreational purposes. They supply some of the industry, like the potash industry requires a lot of water. Municipalities, but for the majority of it, it is directed for irrigation. So again, in Saskatchewan, water is a provincial responsibility. Every province owns and regulates the water within their boundaries. Although there is, as you can see from the last image, that the water does flow across provincial boundaries. That's where the federal government has stepped in and developed these water allocation boards. So there are these long-term agreements between provinces that allow flow between each province, so that because Alberta's upstream, that they don't take all the water, or so they're required to allow 50% of that flow downstream to Saskatchewan, and then of that 50%, an additional 50% needs to be released to Manitoba. So that's how the water agreements work right now. So to become an irrigator or to use water, provinces issue water licenses or water right licenses. So that dictates how and what the water is used for in each province. These vary differently between each provinces, but in general, they're fairly similar, that they're all trying to regulate the water use and trying to protect the resource. So to become an irrigator in Saskatchewan, it's a two-stage process. So the first stage is you require an irrigation certificate. So this is required for all projects over 10 acre-feet, which is about 12,300 cubic meters of water. That's just kind of the low benchmark to ensure that allows some water use on small farms or small, like for market gardens, but on the larger farms, it requires this irrigation certification. These again are administered by the Ministry of Agriculture. It's a process in terms of trying to maintain or ensure that the water and the land being used is of a suitable quality. Then the second stage is to actually get the water rights license. There's so in Saskatchewan, there's two types of irrigators. There's district irrigators, which are part of a collaborative of shared infrastructure, canals, pipelines, and such that distribute water to each farmer. So if you're a district irrigator, you would actually get your license from the district. If you're non-district irrigator, so if you're pumping out of a main supply canal or river or lake, you would get your water license with the province itself. So again, irrigation certification, it's administered by the province of Saskatchewan. So the process usually requires that the ministry will come out and take samples of your soil. They'll test the EC and sedicity of your soil, internal drainage issues, and then the water quality itself. And then if they meet their minimum standards, then you will be issued an irrigation certification. The producer pays this amount. It's about $23,000 or $2,300 per quarter section field. But it's mostly just the cost recovery in terms of administration, the sampling, the processing the samples. So again, yes, if your land and your water is deemed a sufficient quality for irrigation standards set out by the province, then they can issue you an irrigation certificate. So then, as I kind of laid out before, once you have that irrigation certificate, then you can go and apply for a water rights license. So the water rights license for non-district irrigators, this is approved by the Water Security Agency, which is an agency within the government of Saskatchewan. There is an annual fee based on how much water you withdraw. Again, the fee ranges between $100 and $1,000 annually. Really, the fee isn't for the cost of the water. It's more, again, administrative purposes and to ensure that there's that annual fee so that farmers aren't just sitting on that water rights license. They're actually utilizing it over time. So then with the districts, you're actually entering into a service agreement. So the irrigation districts have these complex infrastructure in terms of canals and pipelines, and they have the district itself has a water rights license with the province, but each individual farmer then enters into a service agreement with the district. So I mean, you can kind of envision it as your municipal water supplier, like you paying your local water supplier for water from your tap or your sink. So again, the user pays a fee to this for this service. You're not paying for the water, but you're paying essentially as a cost recovery for maintenance and operation of the headworks. So these irrigation districts right now in Saskatchewan, there are numerous ones. There are 3 or 4 main ones. The South Saskatchewan Irrigation District, which is in red color here. The McCrory Irrigation District is yellow, Riverhurst and Lucky Lake. So these irrigation districts, again, are a group of operators. These districts were originally developed and built by the Government of Canada in collaboration with the province of Saskatchewan back in the 1930s and 40s, and then later on into the 60s and 70s, but have since been turned over to these irrigation district cooperatives, which are the group of farmers that own and operate the infrastructure from the river or the main canal to the farm gate. Just going to note here, there is plans for expansion. It's been to the West Side Irrigation Project and the Coppell Irrigation Project. So these proposed expansions are anticipating to increase the irrigated area by approximately 500,000 acres. So again, the Government of Canada and the province of Saskatchewan historically built the dams and the delivery infrastructure. This was to kind of combat some of the issues of the 1930s in terms of drought and farm, severe drought and losses of farm income, and to promote settlement in the West, utilizing irrigation to drive that settlement. Historically, the governments have owned and operated all of that infrastructure up until the farm gate, and then the farmer entered into an agreement with the province itself. But today, that shift has happened where those the traditionally owned infrastructure has been shifted from the government to the private sector, and so now it's owned in cooperatives or irrigation districts. Governments still own and operate some of the main canal supplies, which then service industries or municipalities, but that has the greater public impact, so they still maintain, own, and operate that. So again, today the government has shifted from building these large infrastructure projects to actually financing. So the Infrastructure Bank recently announced some funding for large-scale irrigation projects. These are long-term loans, low-interest, secure long-term loans. So then the projects will be built in partnership between financing from the Infrastructure Bank, the provinces of Saskatchewan, Alberta, and farm groups themselves investing in them. And finally, the last thing that we've shifted towards is there's still a lot of research dollars to support environmentally sustainable irrigation. Irrigation is still one of the largest consumers of water in Canada. So there is that public good research out there that needs to be done to ensure that the water is being used properly. So again, here's this shift. So irrigation expansion is now occurring in some areas with the recent announcements with the infrastructure bank. But some basins within, some water basins within the Southern Alberta Irrigation District or Southern Alberta are at capacity. And so there's no more irrigation licenses being issued or more water rights being issued. So again, there's that balance that there's expansion in some areas of the country, but there's also restrictions and there's limits placed on other areas just based on availability and infrastructure. So again, we need to make better use. We need to see that as we expand, we are going to hit that cap at some point. So we got to make sure that we make best use of that water and we're getting the most out of that water. And so how do we accomplish that? Genetics, some breeders, we start looking at drought-resistant crops or crops being able to produce more water or produce more with less water. But my areas of work are system efficiencies, so the conveyance and application systems, and the management. So we're looking at how the producer is actually applying the water through scheduling and other methods. So again, here's just a general overview of how irrigation systems are set up in the prairies. You'll have your major river with some kind of diversion, either a canal or either a dam or a weir, divert the water into these secondary canals, and then they can either be removed or they'll be pumped into pipelines, pressurized pipelines for use with all the farmers. But these systems are prone to water losses. The canals are prone to evaporation and canal seepage. Again, if you're using secondary canals, you will have operational spill. So that is return flow, but it is taking up capacity within your system. And then the on-farm. So you're looking at the system itself losing through evaporation, runoff, and deep drainage. So we're just going to look a little bit into some of the solutions here. So conveyance efficiency. So a lot of the main canals have now, originally they were grassed or clay lined. Over years, they've degraded. Since then, we've started moving towards plastic line, and then you put a layer of riprap or rock over top to protect the lining and keep it down. That prevents a lot of the seepage losses that we've seen over the years. So the large canals still require this open canal design. A lot of the smaller canals have since been put into a pipeline or a pressurized line for distribution, and that has saved significant amount of water through evaporation and seepage. Conveyance efficiency. So although the water is being returned, if we can reduce the amount of water that's lost downstream, the canal design itself doesn't need to be as large. We can get more acres out of that same area because we're using that conveyance structure more efficiently. Sorry. So these are just some examples of some control systems that are placed on the control gates at the end of canal systems. So a lot of that has become remote control and remote monitoring. So you don't have, we used to refer to them as ditch riders driving along and having to lift and drop gates and monitor the levels. So system efficiency. So we've come a long way since so this is similar to what was seen early in Saskatchewan, Alberta. This is a flood-based irrigation system. So you'd open the gate water gate at the top of the field, and the water would move down, and you would likely only irrigate once or twice a year this method, just because you are flooding your field and you don't want to damage your crop. Then there was the move towards pressurized lines, and this is a wheel move. So most of you probably are familiar with wheel moves. There's a high pressurized pipeline on wheels that you would sit in place for 8 to 12 hours, and then you would shift it slowly down the field manually. So I mean, it's highly labor intensive, and with the high pressure, also prone to wind drift and evaporative losses. In the 60s to 70s, we started seeing a lot of mechanized irrigation. So this is a high pressure pivot irrigation system. So you're running spray nozzles on the top of the pivot, and then it drops onto the crop. But as you can see on a system like this, it's a fine mist, so it's very prone to wind drift or evaporation. Then in approximately the 90s, Saskatchewan started adopting low pressure irrigation systems, or low pressure drop irrigation systems. So this it's exactly how it says. You just attach the hose to the top of the pivot and you drop the sprinkler down closer to that. And that really helped, especially in Saskatchewan, with the wind drift issues and potential evaporation. And then the final one would be drip irrigation, which is probably the most highly efficient. We still see this a lot in our high value sector. So in our smaller acre, high value horticultural crops, our field crops, we don't use drip irrigation just for the fact of cost and labor requirements. So this is just, I like showing this. This is a plot from Alberta showing the conversion. So the gravity or flood irrigation back in the 1960s used to be the majority of the system used out here in Western Canada. But as you can see now, well, in 2015, we're probably at about 75%. And I would say I think in today, we're probably at 85% of our systems now are the low pressure style. Very rarely are you ever going to see any high pressure wheel move systems unless they're historic based systems that they haven't been replaced. There is the water benefit, but the real driver behind this was the reduction in power requirements to move from a high pressure to a low pressure system. The water savings is important, but the power savings is what really drove it to the farmer adoption phase. Just going to touch base on a few different things. So irrigation scheduling, very important, but sometimes not utilized in the lower cost or the higher large field scale field crops with a lower value. I mean, it can be time intensive to implement. Usually you see this on the higher cost vegetable crops and potatoes out here in Western Canada. Usually on the lower cost crops like canola and beans, you tend to farmers historically operate what they've always operated. So they know approximately what they need. But I just want to, there's some important things as we hit those capacities in some of our irrigation basins, we need to start adopting some of these irrigation scheduling methods if we're going to try to expand the irrigation acres and use the water that we currently have. So just a comparison, this was a modeled output. it's just more for visualization. So if a potato crop out here required in Saskatchewan about 400 millimeters of water to maximize its yield, if we operated inefficiently, so if our systems operated inefficiently, we applied less, or we over applied water, so we had deep drainage, or we had runoff, or we didn't apply enough water at the proper time. So that 6%, or that if we drop to like if we lost that efficiency gains, it's gonna really hit us in the yield. So it's just more to drive home that there are a lot of different methods that we can impose to improve our efficiency of our systems, and that will result in yield improvements. So some of the techniques that are applied out here, soil-based methods. So you hand field method, you go into the field, you take a sample and you feel it for, I mean, that's some people still use it. It's pretty hard to actually get an accurate reading on that. We look at tensiometers. More and more, we're starting to see these TDR or capacitance based, because they can be placed in the field and they have a cellular modem or radio connection based in there, so the farmer can put it out in his field and step away and monitor his soil moisture from his computer or his phone. Other simple methods are irrigation scheduling calculators. I believe the government of Quebec has a calculator as well. BC government and Alberta government and Saskatchewan all have their own calculators, but basically they're climate based. So you're looking at local weather data to estimate how much the crop's using, and then just a simple water balance, what you put in and what comes out. You want those to. Some of the area where I'm starting to do some research are plant-based. So plant-based measurements can't tell you how much water to apply, but they will tell you when to apply it. So we're starting to look at NDVI in terms of crop health, or we're looking at thermal. So if a crop has sufficient amount of water, it should be able to transpire sufficiently and reduce its canopy temperature. If that water is not sufficient, then the crop heats up and it should be picked up in thermal imagery. But I mean, the take-home message again is try to utilize some form of irrigation scheduling. It's gonna, I mean, the water savings are important, but it will translate into improved yields as well. Final area of research that I've been working on out here in Western Canada is variable rate irrigation. So a center pivot like this now will be equipped with water nozzles and controllers. So we have the ability to turn on and off sprinklers as the pivot moves around the field. And by adjusting or pulsing those sprinklers on and off, we can adjust the depth of water throughout the field. So here's kind of a schematic of the polygons within a field, and we can control each the value or the depth of water applied in each one of those polygons. So again, like if you're looking at a uniform rate, if we're looking at irrigation water use efficiency or irrigation productivity, uniform rate, we're going to have areas where it does very well and areas that are not quite as productive. But if we move to a variable rate, we can adjust those rates to match the field conditions and at least maximize some of the areas. We may not improve improve the water use efficiency in some areas. Maybe that's just not a productive area, but we can better utilize that water in other areas by moving to a variable rate system. So most research on average has shown a 15% increase in water use efficiency. Again, that's going to be dependent on your field. Flat, uniform field is not going to have the increases as a quite variable multi-textural field with some elevation differences. Just a plug for where I'm located. I'm in Saskatoon, but I do my work at CSIDC, which is the Canada Saskatchewan Crop Diversification Center in Outlook, Saskatchewan. It's a large multi-partnered facility that focuses on irrigation research and irrigated agronomy. So yeah, again, we fund all types of irrigated research from agronomy to breeding to technology, technology transfer and education. And it kind of covers the whole gamut. So we start in that technology or that research development, move into technology development, and then we transfer to the farmers through training sessions and field days and that. So that's all I've got. So hopefully touched a bit on everything.